Hello and welcome back to the lab. Today on the bench is actually an assembly project that I was able to pick up during the TG501 part 1 and 2 videos where I was going through the very sick TG501. Something in my lab was made blatantly apparent to myself, and that was my lack of a way to test ICs efficiently. I could breadboard them up and test each one individually, but when I have a unit like that that has a ton of ICs in it, that takes a while, especially with the many different types. So I threw together, I'll get back to this is what I wanted to order. So I tossed together an Amazon order because that was everything that I could find, and this particular unit was unavailable during another YouTuber actually showed me this unit, Curious Mark, and that's where I found out about it. But because of his video, everything was sold out and I had to wait, which was fine. So I ordered these two units and did not look at this one very close. No reason for me to order this one. This is one of those component testers, things like that. I'll get a resistor. This is not an IC tester, but if I put a resistor in the test leads. Also, the other thing about this one is the ZIF socket, it just pops in. It's actually harder to pull out than I thought it was going to be, but the ZIF socket just pops in, and if you hit the test button, it wakes up. And it shows me it's a resistor. Now, if you need a component tester, this is a nice little package. Perfect example. Let me get one of these bags here. Here's one. So, like, here's a random unknown part. We'll just put it in, hit test. One doesn't know what that is. That's not good. Oh, that's because with all the ICs I grab a voltage regulator. I think that was a voltage regulator. This should be an IC, or this should be a transistor. Yeah, so it comes out as a component tester. So it's great for checking just various parts and things like that. It did not handle the linear voltage regulator very well. So, but not what I wanted to buy. But a nice addition, and I'm sure we'll find some use on the bench at some point. This was the IC tester that I used for working on that TG501. It struggled, but it got the job done. This didn't work with the decade counters at all, and but it was able to test the inverters and the standard gate chips. So this was the IC tester I bought. Just no name brand, no anything. It's just an IC tester. Now, one of the drawbacks of these is actually drawback of all of them are the chips they ship with that they can test is all they get. I don't know of any way to update the firmware in this to add things to the library or anything like that. So once you end up with a chip that's out of the library, they struggle. So having looked around for a bit and finding out that this has one of the larger libraries other than like a chip burner, which I also need to acquire for the lab, is to get to be able to program EPROMs and things like that. But slowly chipping away at the acquisition list. This, that was upside down, is the Tantek chip tester version 1.2. When you order one of these, this is all you get. You get the board, and you get two programmed ICs. Now, there is a bill of materials for everything else that you need to acquire, things like that, but this is all that comes when the order. You do have to put in an order with one of the parts suppliers. So, that being said, we have a box from Mauser. Now, they are one of the main part suppliers that I use for components and things like that in the lab. I was actually really shocked. I didn't think I was going to be able to build this for a while, because one of the things that's really hard to get right now is voltage regulators, and they had regulators in stock. So now I ordered a fair few amount of parts. So let's see, we have 2 giant bags worth of stuff. Bill of materials, or not the bill of materials, but the packing slip is 4 pages. I will get the bill of materials out for the Tantek, and we will go from there. I did overorder on parts. I have another young engineer who's wanted one, and I made sure I bought enough so he could build his too, since I had them. So, but I also liked it so much, so I ordered 2. So I got 2 sets. I got 2 boards and 2 programmed microcontrollers. Now, this one is PC based, so I will need to interface it with a computer. We have some serial cables, and I have some serial ports that are right here. So we'll be doing all that when the time comes. So you do need a computer to use it, but you do not need to install software to use it, because it's just terminal output into the computer through the serial port. So I'm starting to get a lot of things that talk serial in the lab. The rubidium standard, my GPSDO, my this now. So I may actually need to get a serial switch box, because my lab bench computer, this poor Dell, only has 1 serial port on it. So, and it's a half width. So I don't know if I can put a lot of COM ports in it, but that is going to be a problem for another day. For now, let's get this built. Okay, and looking through the documentation that comes with the unit, we have a parts location diagram, parts list, which we are about to go through and make sure we have everything before we get started. Because with the way components are right now, God knows. Alright, first thing on the list, U1 and U2 are the microcontrollers. Those are provided, so we do have those. U3 is the level shifter. I'll run through this real quick so you guys don't have to watch the tedium of checking in parts. Okay, looks like we do have all the parts on hand to build something, which is incredible given the component shortages, but especially the 5-volt regulators. I was not sure these ZIF sockets are probably the most expensive single piece on this board. I was not sure about these when I ordered these, because I think these were like $30 a piece for the socket. It's a really high quality socket. Here is the part number. Actually, that's the Mauser part number. That's the manufacturer part number. The important part on the socket is, I believe it's the center rail needs to be on the thin side, because if you buy the wrong socket, there's 2 different types that'll fit. You can't test. There's 2 widths of chips that can be tested. You want to make sure you get the right socket to test both types, or you're stuck without it. But I think these are the right ones. If not, let me know in the comments, because that'll just be a quick desolder and a resolder. We'll talk about parts. Bag of diodes. The resistors I picked are better than spec'd. The resistors here were non-critical. They were all quarter watt 5%. I didn't want to mix and match brands of resistors. There's no reason that was forcing me to go a different way. So I wanted them all to be the same, just me being picky. But everything was out of stock. The only thing I could find was metal film 1%. So I'm going to do the whole project in metal film 1% because that's what I was able to order. And the cost difference wasn't too high. Okay, getting ready to solder. I got to set up the fume extractor still, but we're going to start with the smallest components first, which is going to be the 1N4148s, the switching diodes. One good lab tip also is always save the lead tailings that you cut off. Don't throw these away. These things have gotten me out of trouble more times than I can count, so I'm building up another jar of them. So I'll save everything that I cut off of this, tailings and everything like that, and then I just throw them in a jar and as I need them. Short pieces of wire to make jumpers or whatever. These have a million uses in the lab. Always a good idea to save these. Just don't step on them, they hurt. Okay, haven't soldered anything in yet, but I have diodes put in. That should be all of those. So I'm gonna get these soldered in real quick, and then we will move on to a slightly larger part. Oh, it's starting to look nice with a sea of blue. My 220 ohm resistors, I think I may have gotten the wrong size sent by Mauser. So these look like they may be 1/8 watt resistors instead of quarter watt. I checked them on the source measure unit. I ran them at a 1/2 watt of power for hours and they were fine. But I'm going to call them up and see because I'd like it to match. But I put them in for now just to get the circuit up and running, or the tester up and running. But if I do have to replace them all, it's a lot of desoldering, but the desoldering tool's good, so I'm not too worried about that. I also have another board, so if I do end up replacing them all, the other board will get populated with them in the beginning. But this is about after an evening's worth of soldering. It was nice and relaxing. So I'm going to keep going. Got a couple more resistors to put in, and then I'm going to start putting in sockets. So we're getting close to firing it up. Okay, got some capacitors in, crystal, and then sockets, electrolytic caps, voltage regulator, and I think we're ready to turn it on. Well, this build's going to take a little bit longer than I expected. There's always the one part that you don't have in the lab. In my case, it's actually an 8-pin socket. I am totally shocked that the lab's out of 8-pin sockets, but I have to wait, so I'm going to order up some 8-pin sockets, and then we'll finish populating the board. It's almost done at this point. All the other sockets are in, except for the main one in the center, the power supply, and the voltage regulator and bulk filters. So all in all, it's looking really good. This is an LED down here with a brightness resistor, current limiting resistor. Yeah, I'm happy with that so far. Well, it turns out I grabbed the wrong part number. I dove into the data sheet. The MFR25S, which is this one, is the miniature quarter watt. So this is these are quarter watt resistors. These are full normal size, and then these are miniature. So yeah, everything's right. Just one part number off. They will work, though, in this application. And we have it assembled. Also, it did bug me. I got 220 ohm resistors. I'll be adding those in to the next board that I have to build. I have to assemble one more of these. We'll populate this with chips. I did get the 330 ohm resistor for down here, but this is a high brightness LED, so I damn near went blind when I turned that on. It was wildly bright. So I had to upgrade that to a 2K to cut the brightness down on that LED. But here we go. It works. I got to put chips in and get it hooked up to a computer, and then we can test it out. And the boards are done. Here's the first one. I haven't changed these resistors yet, so they still have the smaller miniature ones. This is the second board that I ended up building up. Main differences are I had a shrouded serial connector. These worked along with these cables. The pinouts worked correctly. I haven't tested them yet, but we'll see how it goes. Yeah, so let me grab the laptop and we'll get this one set up. The second one I built. We'll get this one tested first. See how it goes. Okay, the tool I'm using to access the chip tester is just a terminal software called Putty. It's in the Windows world. I created a profile, the Tauntek IC tester, and it's just 9600 baud straight serial data out. So we'll start the session and let's turn on the chip tester. And there we go. And the moment of truth. There we go. All right, let's get some ICs. So I just had a 74LS90. Said it found it in the database. So I'm going to move over to the chip tester and then we'll test it. So on this particular chip tester, the IC goes at the bottom with the pin with pin 1 facing up towards the top. So we're in the socket. And now we hit T for test. And there it goes. Now this was one of the reasons why I liked this chip tester. So the chip tester applies pull downs and then it measures the current at VSS. So for this particular IC, with all the pull downs applied, it's measuring about 16.1 milliamps, and then it pull down resistors, looks for shorts or leakage, then it checks levels. So if an input was outputting a voltage or something, depending on how the chip died, it would fail this test. It actually, the database knows the voltage thresholds for the logic highs, logic lows. But then the other thing that I really like about this is it does the truth table. So as it's rolling through and doing everything, it really exercises the chip and takes a look at all the parameters. So this will find chips that a lot of testers won't. I'm sure this will fail chips that my generic chip tester will pass. So let's check some other ones. Okay, I couldn't find my presettable counters, but that's fine. Here's a 74LS32. I was sure this was going to be in the database. Wow, 2.9 milliamp. This is a new modern IC that I've got for some of my, for a 7854 project. So I'm actually quite surprised on the current draw. That's nice. 74LS 30. I was sure that one was going to be found. There we go. Wow, just a milliamp. That's pretty impressive. It might have these, it may not. 74LS 374. I did find the flip-flop. Very cool. I am very curious to see what a flip-flop test actually looks like. It even checked the tri-state outputs. Very cool. Well, I'm happy with that. Well, I will probably have to build 1 or 2 more IC testers to cover as many chips as humanly possible. I would like to be able to test some SRAMs and things like that for some of the older rebuilds that I'm looking to do. But I'm actually quite thrilled with that. Well, thanks for stopping by the lab, taking a look at the Tauntek IC tester. These will be a great addition to the lab to help with troubleshooting some of the logic in the devices that I'm starting to work on. So I got to figure out a good way to integrate this into the lab bench. Probably going to do a switch box, a serial switch box, because I now have 3 things that run on direct serial input, and my bench computer, given that it's a mini form factor, it only has 1 serial port. So that's a problem I'm going to have to solve. But other than that, excellent if we ever have to test any more logic. I'll see everybody in the next video. Bye for now.